So in this section, we are going to learn about time series and sequence data. What are they? So I cannot explain many things, but let's just learn the basic idea of the time series and the sequence data, and then how we can do with some kind of trend analysis. And there are some concept about the similarity search and the distance measure. So we have another distance measure and how we can deal with the text data. Time series and the sequential data is one of the important data types in these days. When we have the time series data, we will have the time series database. What is time series? So it is a sequence of values or sequence of events changing with time. So we have the time data. And data is recorded at regular intervals. What does it mean by regular intervals? It can be daily, or it can be weekly, or it can be monthly, or it can be yearly. So it is regular. Or sometimes we can also have like hourly, or maybe it is every minute or every second. So if your database is good enough, then you can get data in every second. And there are some characteristics of the time series. We can see the trend, or we can see cycle, we can see the seasonal, or some irregular patterns. The irregular patterns, for example, the pandemic pattern, the pandemic time, it is irregular because it is not common in the world. So when we are dealing with the applications, so we can see from the financial stock. So it is one of the application in the time series database. And then inflation. When we are dealing with the economic, of course, it is the time series. Biomedical. So if you can measure your blood pressure, maybe you have the medical checkup for every year or every 2 years, then they will have this kind of information in the database, and they will give you like some health information based on the blood pressure that has been stored. Or the meteorological, for example, the temperature, precipitation. So when will it rain? When was it raining? And etc. So it is related with the time series and the sequence data. And when we are dealing with the time series, one of the analysis is about the trend analysis. In the trend analysis, it is we can see the time series as the time series graph. So the most common approach when we are dealing with the time series is to create this kind of graph, and then we can describe a point moving with the passage of time. So x is the time, and then we can see what are the patterns. So there are some categories of the time series movement. The first is the long term or the trend movement. So if this is the observation data, So this is the actual data. So if you look at this data, we know that, yeah, it's like growing. So we call this is trend. If we have cyclic, or cyclic movement or cycle variations, so we call this is the cycle. The business cycles, for example, yeah, we have every year, or maybe we have the business cycle in every January, or we have the business cycle every Christmas. Seasonal, or seasonal movement or seasonal variation. We can it's almost identical pattern that a time series appears to follow during the corresponding months of successive years. So you know, if we have winter time, we have summertime, we have springtime. So if it is summer, then yeah, it is time for going to the swimming pool. If it is winter, then many store will sell jacket. So that's kind of seasonal. Yeah, we can see the pattern. But there might be some kind of irregular or random movements. It means, yeah, we don't know the patterns, just random. We can do some estimation. If there are some trend, then we can have three methods. The first method is freehand method. The freehand method means we fit the curve by looking at the graph. So we have this graph. So this is the actual data. And we try to fit in. The fit in just, yeah, we draw the line. Okay, it seems that this is a trend. With this freehand method, it is costly and barely reliable for large-scale data mining. So if the data is only like, this one is 6 years, from 1972 until 1978, yeah, it's very small. So you can use the freehand method. So you can just have your own analysis. But if the data is too big, then it is not reliable. The other method, we call it least square. So the least square method is usually a method for the regression. We want to find the curve minimizing the sum of the squares of the deviation of points on the curve from the corresponding data point. So the least square. The least square means we have the actual data. Let's say this y. Let's say this yi minus the y prediction. The y prediction is the line that we want to draw. And then we do the square. Okay. That's what the meaning by the square. And then we will do the summation. The summation is from the I equal to 1 until the n data. So if you have like this one, this is the data. So we will check the error. So this error, and then we have also another error. We have also another error. We have also another error. We have also another error, and so on. And we know that this line, it can be mentioned as this equation. So x equals to the beta 1a plus beta 0. So we want to know if we draw this line, how big is the error? We call this is the least square method. We can have another method, we call it the moving average method. We can eliminate the cycle, we can eliminate the seasonal, we can eliminate the irregular patterns. And then we need to check the loss of every end of the data. However, it is sensitive to outliers. So among those three, of course, there are also other methods, but this is the basic trend analysis. So let's see the simple moving average. We have the period. We have period 1, period 2, period 3, 4, 5, 6 until 12. Okay. And then this is the actual data. Yeah, this is just an example. Okay, let's say this is quantity, for example. In the period 1, a store can sell 42 items. In the period 2, the store can sell 40 items. In the period 3, the store can sell 43 items, and so on. So we have 12 periods. Now, I'm using this moving average. I want to forecast. So starting from 4th period, one can start forecasting by using MA3. What is MA3? We call it the moving average with 3 periods. If we have 3 periods, it means I would like to have the period 1, the period 2, the period 3. So it means 42 plus 40 plus 43. And then I would like to divide it by 3. So the result is for the 1.66666 something. So let me just make it 41.7. And this value will be the forecast for the period 4. Because this is the MA3. What about the period 6? If we have MA5, it means we have the moving average for 5 period. It means I will do the 42 plus 40 plus 43 plus 40 plus 41 divided by 5. So the result will be for the forecasting on the period 6. And what about this one? How can we get this? 41. If it is MA3, and if we want to predict the period 5, it means we will do the period 2 plus 3 plus 4. So it means 40 plus 43 plus 40 divided by 3. Then we will get a value which is 41, and 41 will be the value of the forecast. So we call this is the forecast with MA3. And this one is the forecast with MA5. Okay. we say that this is the actual value. So this is the actual value and this is the predicted value or the forecasted value. You can plot it. So yeah, this is the actual data. The blue color is the actual data. And then you can plot the MA3. The MA3 is in the pink color. And you can plot the yellow color. The yellow color is the MA5. So I want to know which one is the better, MA3 or MA5. Which one is better? Then we need to calculate the performance. The performance is using the error rate. I think you know already, when we do the regression, we have some error measurement. We have the MAE, which is the mean absolute error. Here we have the mean absolute error. And we can also use the MSE, which is the mean square error. You can have also RMSE, root mean square error. So the basic idea can be used also in this moving average, or this is the time series data. So we have the Y, which is the actual, and then we want to check the error rate. The error rate is the deviation between the prediction and the actual. The Y hat is the prediction, the YI is the actual, and we want to know the deviation. The deviation means the subtraction, and then we give the absolute function. The absolute function means we will turn the negative into positive. And then we will divide it with the number of data, K. So for example, I want to know the error rate of MA3. So the MA3, we know that it is based on the 3 periods. Then the forecast starts in the period 4. Then, since the data exists until period 11, we calculate the error from period 4 to period 11. So in the period 12, we don't have any data. So we cannot check with the actual data. Then we will do the error only based on the period 4 until 11. It means we can do the subtraction between this value and this value. 41.7 minus 40, and then 41 minus 14, 41, 41 minus 39, 41.3 minus 39, 40 minus 46, and so on. And then we will divide with the numbers of the data that we have. So we have 8 data, then we will divide it by 8. And then we will check what is the value of this error. Okay, we have 2.9125. So you can do the same with this. You can use the same way. So we can check this number, the predicted number, with the actual value. The predicted number with the actual value. The predicted number with the actual value. And then we will divide with 1, 2, 3, 4, 5, 6 data. And based on this error rate, you can check which one is the better, whether it is MA3 or MA5. So which one is better, MA3 or MA5? So the lower error is the better. Okay. So you can calculate the same If you use MAE, then the error rate will be based on this one and the MAE for this one. If you use MSE, yeah, you can check also which one is the lower. The lower error is the better. There can be another way to do some time series analysis. We can do the similarity. When we are doing with data mining, when we do the clustering, we want to check the similarity between objects. So we can do also the similarity search in the time series analysis. In the normal database, you can query to find the exact match. So if you use the SQL, if you use the structured query language, you can find, is there any item equal to jacket? Then, we will find the item name equals to jacket. But if we want to find the similarity means maybe it is not equal directly to jacket. Maybe some keywords like jumper, or they have another keywords, not jacket. But in the time series, we can also find the similarity to find the data sequence that differ only slightly from the given query sequence. So there are two categories. The first category, we call it hole matching. So we want to find the sequence that is similar to the query sequence. Or we have subsequence matching. We want to find all pairs of similar sequences. We can use some of this into the financial market or the market basket data analysis. I think you still remember this one. It is from the association rule. Scientific database. Scientific database, usually we use this one for the DNA, analysis, or if you learn the genome sequence, we can find whether two persons are brother and sisters. So we can use also this kind of similarity. Medical diagnosis. So we can find whether the person is having a certain disease or not. So what we are going to learn today is the subsequence matching. In the hole matching, you can look at all the data, and then you can look at the other data, and then you can match for every of the item. So you already learned about the cosine similarity. You already learned about the some other similarity like Euclidean distance and etc. So you can use that one for the hole matching. But if we are making the subsequence means I just want to see some part of this time series. So we can break its sequence into a set of pieces of window with length W. So we call it window. And we have the length W. And then extract the features of the subsequence inside the window. So let's say, in this case, I want to see x2, x3, x4, x5. Which subsequence contain the x2, x3, x4, x5? So after I know the first window, x1, x2, x3, x4. Then it means I will check the distance. So you can see this one. If we can see the distance, this is the second distance, this is the third distance, this is the fourth distance, this is the fifth distance, and so on, then we can check later. We can map each sequence to a trail in the feature space. So this is the trail. So we can do first, and then we can do second, and then we can do the third, and then we can do the fourth, and so on. So divide the trail of each sequence into subtrails and represent each of them with a minimum bounding rectangle. So if we have this kind of distance, then we will check which distance is appropriate for the selection. So whether some distance is in the exclusion zone or some distance are included, and so on. And we can use a multi-phase assembly algorithm to search for longer subsequent matches. So if we have longer, then we can use another algorithm. We call it the assembly algorithm. So this is the basic idea. So let me just give you one example about one algorithm. We call it dynamic time warping. So the dynamic time warping is one of the famous algorithm, DTW, dynamic time warping. It is a distance measure that compares amplitude of first signal at time t, and then we want to compare with the amplitude of the second signal and the time t plus 1 and t minus 1, or t plus 2 and t minus 2. So this makes sure that it does not give low similarity score for signal with similar shape and different phase. So let's see like this one. If you use the Euclidean matching, you will just check particular time with another value in the same time. You will check this time and another value at the same time. But with the dynamic time warping, we are going to check this time with different time. Maybe we can have t plus 1, t plus t means time. So I want to check, for example, I have the data on January 2020. I want to check with the January 2021. I know January can be compared with January, but sometimes we need to check also not based on January and January. We need to check the January 2021 with the February 2020. So we need to check with the surrounding time, because maybe the company, for example, the company start late. So we need to check with the February 2020. Or sometimes we can check with the December 2019. So the surrounding date will be covered with the dynamic time warping. This is the algorithm. Let me just skip the algorithm. Let's check the example. It will be easier for us to see the example. Now let's see, we have two series. We have P and Q. Okay. Maybe you can think like this is a stock from one company and this is stock from another company. So on January, the price is 1, and the other company also the price is 1. In the second period, the price is 4. In the second period, this price is 7, and so on. So it is a time shift. So if we plot, it will be something like this. Now we want to check the distance between these two time series. So first, we will make the empty cost matrix. We call it, this is empty cost matrix. We have the Q and we have the P. So the P is the value. We have 1, 4, 5, 10, 9, 3, 2, 6, 8, and 4. Q is the value of the Q is 1, 7, 3, 4, 1, 10, 5, 4, and 7, and 4. So what we are going to do is to fill the cost matrix using the formula, starting from the left and bottom. So we start from this. The first is M1, 1. The value will be 0. We will use this formula. The Mij, it means the position I and the position j, M1, 1, it will be the P1 minus Q1, and then we make the absolute, plus the minimum of Mi minus 1, j minus 1, Mi j minus 1, Mi minus 1 j. So we want to check the minimum. Now we have the M1, 1. P1 is 1. Q1 is 1. Then 1 minus 1, it will be 0. For this one, for the minimum, we don't have any box here, so it will be 0. Then the minimum here is 0. Next, I want to check the M1, 2. M1, 2. Here we have the P1 is 1, Q2 is 7. Then 7 minus 1, we have the absolute. So the result is 6. And then we need to check the minimum. Minimum I minus 1, this is M0, 1. And then M1, 1. And then M0, 1. M0, 1, of course, no. M1, 1. What is M, 1? 1, 1? It is 0. What is M0, 1? No. Then the minimum of 1, 1 is 0. So we have 6 plus 0. Then it is 6. Next is M2, 1. M2, 1, it means we want to check here. So this is the 4 minus 1 absolute plus the, because it is M2, 1, then we will check the minimum of the 1, 0, M2, 0, M1, 1. 1, 0, we don't have any data. M2, 0, we don't have any data. M1, 1, okay, we have the data is 0. Then 3 plus 0, then the result is 3. Now next we have M1, 3. M1, 3, it is here. Again, we are going to check the subtraction 3 minus 1. 3 minus 1 absolute plus the m I minus 1, which is 0, comma 2, and then m I, it is 1, comma 2, and then m I minus 1, this is 0, comma 3. For every 0, we don't have the data, but we have the data m1, comma 2. What is 1, comma 2? The result is 6. Then we have the result from this subtraction. It is 2 plus the minimum of 1, comma 2, which is 6. Then the m1, comma 3 is A. Okay. Next, 2, comma 2. We have 2, comma 2. It is 7 and 4. So 7 minus 4. Now we will check the m I minus 1, which is 1. J minus 1 is 1. Comma m I, it is 2. Comma j minus 1 is 1. And then we have the m I minus 1, which is 1, comma j is 2. So what is m1, comma 1? 1, comma 1 is 0. Okay. And what is m2, comma 1? m2, comma 1 is 3. And what is m1, comma 2? m1, comma 2 is 6. So we have 0, 3, and 6. What is the minimum? The minimum is 0. Then we will get 3 from this one plus 0. Then it is 3. And so on. Until we got the complete numbers. Okay.